really, what I want to do is talk about Soundly's experiment, because Soundly's released his evidence for, or his results of his experiment that he'd done. And I'm going to start with a massive thank you to Soundly, and obviously to Jesse and the volunteers that were involved in the experiment, because without these people, this observation would not have happened. So massive thanks, shout outs, and all credit to the guys that were involved in this. This is really good scientific empirical data that we can all use, and there's not a lot left to the imagination from this one. I appreciate, and I'm sure everybody appreciates, that Soundly has spent a lot of time, preparation, risk. I mean, the guy's risked his life by playing with it in a canal or a bayou. I think the best word to describe it for the English people is a canal that is alligator infested. I mean, that's crazy, right? So massive shout outs to everybody that did this. And for those that are not familiar with what's happened, he's put his P900 on a tripod at the beginning of the bayou. And then what he's talked about is the effects of refraction from the outset. I'm not interested in the refraction. I'm interested in the curve, because what he shows is, as he's going up and putting all the lamps on the what he's doing is he's putting a lamp on every mile marker on the post that's nearest to the mile marker. So it's not an exact marked mile, but it's close enough. I'm live. She's in the mood. Anyway, so he's put a lamp on every mile marker out to the 8 miles. And what I've done is where is my thingy gone? There it is. I've done the maths for what is the expectation on the model. And essentially you've got the 8 mile markers down here, and then you've got the drop that is supposed to be observed from this experiment. So obviously from the first mile marker, you're not going to see anything. It's 8 inches from the front. Well, the first mile marker is the first one we see on the shot. He has got one further to the right, but it's out of frame. 32 inches becomes 5 feet, becomes 9 feet, becomes 14 feet, and it goes up exponentially as it gets towards the end. Now, I was in Imrich's channel recently, and Soundly caught up with me in there, which is great, because we were able to talk like adults, and we were able to just chat, and we did. And thanks to Imrich for allowing it to happen. And thanks for Soundly for coming in. And what I was able to get from Soundly was what was his prediction. Because my prediction was based on the Taboo conspiracy videos, which were based on 8 miles. And he could see clearly the light. Soundly said, it was poor quality, it was out of focus, it wasn't good enough to make any real observations. And I said, well, the fact that we can see the light at 8 miles means that we're going to see all of the light. We're going to see all of the lights. What's your position? And he said, there'll be definitely lights missing. So my previous video, or my most recent video, was playing back the observations that Soundly had, or the predictions that Soundly had made. And basically what had happened then was Soundly attacked me for quote mining.
Are you okay?
Yeah, she's in a mood. He attacked me for quote mining. So what I want to show is basically the confirmation bias from a couple of his comments. Essentially, look at Miles, for instance. Awesome Soundly. I can imagine a lot of flat earthers challenging the refraction effects soon after darkness. No one's interested in the refraction because it's negligible and not worth calculating for. Also, good to see the camera height confirmed as plenty high enough to see all of the lights. This is just confirmation bias in its total perfection, right? Because the maths is not supporting you seeing all the lights. Soundly's prediction was based on the maths, and the prediction and the maths showed us that we should not see all of the lights. So he claims that I'm going to claim some sort of Pyrrhic victory. Forget the refraction. We can do it on the maths, because we know that he's got a measured 5 feet above the water. Soundly says that I was lying, and I quote mined, and I mischaracterized what I said. I didn't. I played it in context, and I said exactly what you said. So obviously I've responded saying, I don't think you guys understand what standing by your words actually means. It's not quote mining, it's citing you and your prediction exactly how you did it. So watch this space. That's what we're going to do now. Now, on his video, you only really need to see one frame, because you can pick any frame out of the results that he's got, and they all do exactly the same thing. This is the first light that he puts in. There is one off to the right, but this is his first one. And then second, third, fourth, fifth, sixth, and then seventh. So that must be the eighth. 7, 6, 5, 4, 3, 2. Maybe there's another one down here. Oh no, so the first one's just off screen. But because we know that they're a measured distance off the surface of the water, and he's measured them at 5 feet, it means that we don't need to be on any particular angle, because we know that this is measured up to the surface of the water. So all we need to do is put a straight line on it and see what it shows. And what then we see is that they're as flat, it's basically as flat as a pancake. So the first one has got more glare to it because it's closer, but that's just touching the glare. This one drops. That one is about the same distance away, little distance away. Then it starts to go back up again, and then it goes back up again. So we are seeing a little bit of refraction, but the refraction is exactly what we would expect to see when applying the Skunk Bay footage, which is this one. So the Skunk Bay footage shows that when we observe refraction, we see that there is variations based on depth. And sometimes they're taller, stretched and shrunk, and sometimes they're smaller, stretched and shrunk. And it's all to do with the distance that you're looking, and it's to do with the vertical element of the shot. It's not anything to do with arc mathematics. It's the variation on the pressure vertical, which is what we see in the Skunk Bay. And we can apply this directly to what we see with Soundly. Now, when Soundly's done his experiment results, it's worth going back to paint for a minute, because you can see that it's a dead straight line. But when you go back to the actual maths, according to their maths on their model, the 8th mile marker should be 36 feet below the first. There should be 36. That's like six Soundlies stood on top, like shoulder, one on top of the other, on top of the other. There should be 6 Soundlies stood between that one and the first one. Now, there clearly isn't 6 Soundlies at the back. So you've got to go with the perception that if we can put a straight line over them and they don't show the required level of curvature as per their maths, the only logical conclusion that you can come to is it's either flat or no less than inconsistent with the maths that they present. This is not reflecting the curvature of the Earth. There is no evidence here to support it being a curve. Even if, I mean, the refraction is minuscule and it's not worth calculating for. I'll just show you that that is what the authority for that is. It is this one. No, it's not. It's the next one. So it's that one. So refraction, this is cited from an article that Mick West suggested that I read, which I did read. And it says, under standard circumstances, the effects are negligible. It's under non-standard circumstances where refraction, you can see things like Fata Morganas and whatever, but normally the effects are negligible. And then you have to consider what the meaning of the word negligible is, because for some reason this is where the refraction argument gets distorted out of all reality. But the word negligible simply means so small or unimportant as to not be worth considering, or insignificant. So refraction effects in normal circumstances are insignificant, which is, of course, what we're seeing here. We're seeing a little tiny bit of shimmer on some of the lights. I mean, that one's clearly got a little bit of refraction, but it ain't bending behind no curve. It ain't dropping off in any curve. And you can see that the 5 meter or the 5 feet that he's measured from the water surface is consistent with the reflection, and it's all the way across. If this really was bending over the curve, as you get further and further away, this distance here should be getting smaller and smaller to the point where it extinguishes. Now, the argument here is going to be, well, it's the observer height. You're far too high. You're not going to see it. Well, it doesn't matter if we've got a measured distance above the water, because we know that that's 5 feet and that one's 5 feet and that one's 5 feet. These are all 5 feet above the water. Put a string line across the top of them. If it's flat, it's flat. It looks flat. It does not look curved. It is not conforming to the math that they say. So, unless there's some other magical way to interpret these results, the simple fact of the matter is that Soundly's now got evidence that's completely inconsistent with his model, because we are not seeing 36 feet worth of difference at the other end. It lines up perfectly. So now the question becomes, is there any other way that we can interpret this evidence soundly? And if there is another way, can you show it? But the reality appears to be that it's no less than bigger than what they tell us. Geometrically, it's bigger than what they tell us. But it appears to be flat. Standing water, it appears that you've just confirmed the Bedford Levels experiment. It appears that Wallace was wrong to claim a victory, which I've said from day one he was never entitled to claim. You're supporting the Bedford Levels experiment results. You're supporting that Wallace was wrong to claim a victory. Now we can understand why the other guy lost his temper and ended up in jail because he was fighting all the time because he knew it was fraud. So the question is soundly, is there another way to interpret these results? Or is it exactly the way it appears? It appears to support the assertion that the Earth is not a ball of a circumference of 25,000 miles. It's flat. And if it isn't flat, it's got such a little amount of curve in it that it's significantly bigger than what we're told. So show us the explanation, Soundly. Where are we going wrong with the results? Because it appears to be consistent with us and not consistent with heliocentric ball maths.
Very cool.
What do you think, Nate?
Very cool indeed. Very nice. I'm going to run through a few of my links, then minimize your screen share, providing you're done screen sharing, that is.
But massive shout out to Soundly though, because I think we all appreciate that you have actually done something really credible here, and it's really good that it's been a doubling up with Jesse. So massive thanks to everybody who's involved. We all appreciate it, and thanks for risking your life. But yeah, that's me done. I've got to go and do a bit. So I'll leave that one with you, and thanks for not sniping me, trolls. Oh, couldn't do it, could you? Damn.
Massive thank you to Anthony Riley. If you are new to this channel, or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate.